Hey guys, welcome back. Today we're going to be talking about 8.9 graphs of linear inequalities. So we've talked about linear equations before, but remember with equations, it means there's an equal sign involved. Now with inequalities, means these are not equal. In other words, instead of having an equal sign, it's going to have a less than, a greater than, less than or equal to, or a greater than or equal to sign. So still treat them the same when it comes to like solving and things like that. However, we're going to use your answers are just going to look different essentially. So the solution of a linear inequality is instead of being just an ordered pair, now it's an entire range of ordered pairs. A range of ordered pairs that make the inequality true. Okay. Now a graph of a linear inequality, again, instead of it just being like some sort of line like this, it's going to be an entire shaded region. So it's going to be the set of points in a coordinate plane that represent inequalities solutions. But again, instead of it just being a line, it's going to be an entire shaded region. That's why it's going to look different about it. Okay, so on 1 through 5 on your homework, it's going to ask you to check the solution. So yeah, on 1 through 5 here. So, for example, on this one, it's going to ask, it's asking is 3, 0 a solution? Okay, so remember, the first value is always x, the second value is always y. First value is x, second value is y. So in this case, we're going to plug in 3 for x, and we're going to plug in 0 for y. So it's 3 times 3 minus 0. Oops. And we're going to see, is that actually greater than 2? Well, 3 times 3 is 9, minus 0 is still 9. Is that in fact greater than 2? Yes. So 3, 0 is a solution. Now when we look at this one, again, we're going to plug in -1 for x on this one, and we're going to plug in 5 for y. Well, 3 times -1 minus 5. Well, 3 times -1 is -3. Minus 5, well, that's going to be -8. Is that greater than 2? No. So -1, 5 is not a solution because that is not a true statement. This is, that's why this is a solution. So on these, when we check, we go negative, and I always, whenever you plug in, always use parentheses. -1 plus 2 times 6 is greater than 4. So -1 plus 12 is greater than 4. So 11 is greater than 4, which is true. So yes, that is a solution. In this case, -7 plus 2 times negative 2, is that greater than 4? Well, negative, negative, positive, positive. 7 minus 4 is greater than 4. 3, is 3 greater than 4? No. This is not a solution. Negative 2 plus 2 times 3 is greater than 4. Again, I'm just replacing this is x, this is y. This is x, this is y. This is x, this is y into those spots. So yeah, I get negative 2 plus 6 is greater than 4. 4 is greater than 4. Now, 4 is equal to 4. It is not greater than 4. So actually, that is not a solution either. Now, graphing, this is going to look like 12 through 16 on your homework. So on here, let's see here. It says draw the boundary line, y equals negative x plus 1. So y equals negative x plus 1. Whenever we graph, remember it's y equals mx plus b. Remember, b is your y-intercept. M is your slope. You guys get to do this a lot this chapter. So my slope in this case is negative 1. So it's negative 1 over 1. And my y-intercept is 1. So I go up to 1 first, because that's my y-intercept. I do that first. And my slope tells me down 1 and tells me right 1. So down 1, right 1. Or negative 1, it could also be 1 over negative 1, because a positive divided by negative is still negative. So I could go up 1 and left 1. Notice it's going to form the exact same line no matter what I do here. So it's going to look something like this. Okay, now we're going to test a point. And yeah, and remember, greater than or equal to is a solid line. If this was just greater than or less than, remember those are dotted. Greater than or equal to or less than or equal to are solid. So make sure you get make a note of that. So yeah, this is a solid line, which is why we made this solid here. Now, in this case, we're going to test, is this point, because plugging in zeros is a lot simpler than plugging in other numbers. So if this point here is true, that means everything else here is true. However, if this is false and that makes the statement not true, it means none of this is true, which means all of this will be true. So we're going to see which one it is. So when I plug in zeros, I plug in 0 for y, and I plug in negative 0. Cool. Well, negative 0 is just 0. So is 0 in fact greater than or equal to 1? No, it is not. So that is not true. It is not a solution. So if this is not a solution, that means this must be. So if I plugged in the point 1, 1, that would be true. If I plugged in the point 2, 1, that would be true. If I plugged in the point 1, 2, that would be true. 2, 2, all of these would be true. So for example, if I plugged in 2, 2, I'd go 2 is greater than or equal to negative 2 plus 1. 2 is greater than or equal to negative 1. Is that true? Yes. And I knew that was going to be the case because it lies within our shaded region. So shade to half plane that does not contain 0, 0. That's how you determine. So on your quizzes, on your homework for 12 through 16, it's probably going to give you 2 graphs with the same line, but you have to decide which side is shaded. And you do that by plugging in zeros. Again, if 0, 0 were true, if this point were true, we would shade this side. In this case, it wasn't true, so we shade the side without 0, 0. All right. graphing linear inequalities with only one variable. So x is greater than -2. So when we graph the line, x equals -2, but this is just a less than sign. So this is going to be a dashed line. And we're going to use 0, 0 to test the point. So x equals -2, or where does x equal -2? Up, down, left, or right? Left 2. And all of this, and we said it'd be dashed. Now we gotta decide, is it shaded on this side? Or is it shaded on this side? Let's find out. It says 0 greater than -2 when I plug that in. Well, is 0, when I plug in the point 0, 0, is 0 greater than -2? Yeah, it is. This point is true. Therefore, shade the half that plane that contains this point. In other words, all this gets shaded. All right, y equals 3. Now, where's the point y equals 3? Do I go up, down, left, or right? 3 to get to there. Well, it's positive, so it's either right or up, and it's y, so that means up. So I go up to 3 here. Okay, so I mark this point. And remember all this, and because it's y is greater than or equal to, this is going to be a solid line. So here we go. Again, we're going to use the point 0, 0, so 0 less than or equal to 3. Is that true? Yeah, it is. So again, we're going to shade the one that contains 0, 0 in this case. So I'm going to shade all this because it was true in this case. Now for 6 through 10, they're not going to come out as y is less than or equal to or y is greater than or equal to. We're going to have to get y by itself. So remember, that's how we do this. There we go, reverse order of operations. Whenever we solve, we go this direction. So we start with addition and subtraction, then we look to multiply or divide. So in this case, if I'm trying to get y by itself, first I have to get rid of the 6x because it's being added. Remember, we always look at the number that's ahead of it, the sign ahead of it, so it's positive. So if it's positive 6x, I need to subtract 6x from both sides. 9 and -6 are not like terms, so I'm going to have to just leave them apart. Now, I already added and subtracted. Cool. So next, I have to look to multiply or divide. Well, y is being multiplied by -3. Opposite of multiplying by -3 is dividing by -3. Now, there's one tricky thing here. When you divide or multiply by negative, what do you have to do with the sign? You gotta flip it. So instead of it being y is less than, now it's y is greater than. Negative divided by negative is positive, so it becomes 2x minus 3. Now let's graph. 2x minus 3, that's my y-intercept, so I go down 3 to this point. And then my slope, remember, is 2 over 1. So since it's 2 over 1, that means up 2, and it means right 1. So from this point, I go up 2, right 1. To this point right here, up 2, right 1. And I'm going to connect these. And it's going to look like that. Now, from there, I have to decide, well, is the shade on this side with the 0, 0, or is it shaded on this side without the 0, 0? So let's test it. I'll go off to the side here. 0 is greater than, oh, and it's greater than, so I should not have made, this should be dashed. It's going to be a dashed line. Gotta be careful of that. So I go 0 is greater than 2 times 0 minus 3. 0 is greater than -3. 0 is greater than -3. That's a true statement. So that means all of this is shaded. Right? And now this one, x, last example, x is less than or equal to 4. So it's x, so that means it's here. That's a solid line because it's less than or equal to. Now, when I plug in 0 is less than or equal to 4. Now, is that true? Yeah, 0 is less than or equal to 4. So that means all this is shaded. And there you go. That is how you do 8.9. So remember again, 6 through 10 in your homework is going to look a lot like this. So make sure you solve for y first and then put it in a slope intercept form and graph from there. As for the rest of them, they're going to look something like this. 12 through 16 are going to look like this, where it's going to, it's going to give you the graph, and then you're going to have to decide what the equation is based on the graph. And then the first 5 are going to look like this, where you're going to be given an equation, and then you have to test points by plugging them in to see if they're actually true. All right. Again, let me know if you have any questions on any of that. Good luck on your quiz, guys.